Welcome to Kyvos training. In the previous session, you learned how data is processed for Kyvos semantic models. In this session, you will learn how to refine and optimize the created models. There are two views of the semantic model, the physical view and the logical view. The logical view is intended for business users, while the physical view is for designers. When you query the model, you see its logical view, not its physical view. Consider splitting the dimension to improve the query performance of attributes in a high cardinality dimension. For example, if a dimension D1 has two attributes, A1 with a cardinality of 100K and A2 with a cardinality of 10, querying for A2 would unnecessarily process 100K records. By splitting D1 into D11 with A1 and D12 with A2, the query will process only 10 records instead of 100K when A2 is used. This significantly improves query performance. Thus, splitting the high cardinality dimension into two improves query performance. Now, let's examine a scenario involving reduced dimension cardinality. Suppose dimension D2 has about 5 attributes with a cardinality of 100K. Currently, we are querying for A1. Although there are only 10 distinct values, we need to search for these 10 records out of 100, significantly impacting query performance. By splitting the dimensions, we can logically map A1, A2, and A3 together, and A4 and A5 together, reducing the number of combinations and improving query performance. Assuming the maximum value for these combinations doesn't exceed 200, and each combination remains below 15, this will be the cardinality result after completing the semantic model process. For demonstration, the maximum value is selected. Considering these scenarios, we will split the dimensions. Now, let's open the logical and physical designs. The physical and logical designs are the same, but for demonstration, we've kept them separate using different semantic models. Open these semantic models. Now you can view the physical view and expand the customer dimension. Expand the customer dimension and then the customer account. Here, the customer dimension contains ship-to-ID and 3 attributes moved here as all customers ID, total market desk, and account. Let's view the semantic model job summary. Click the Job Summary tab. You'll see the customer dimension with ship-to-ID at 61. This scenario has high cardinality, assuming it's 610K. To serve this record, you must read these 610K combinations. When querying all customer IDs and total market descriptions, this dimension is used. However, searching 610K records to retrieve values requires significant processing. We've split them in the physical design. Click the Process tab, then go to Job Summary. Customer is the first dimension, and Customer Account is the second dimension. We've moved account to hierarchy levels due to its higher cardinality of 24. This includes total market descriptions and either customer or customer ID at the attribute level. By querying this, we access fewer records to obtain total market descriptions and all customers. Notice the difference between the job summary and logical and physical views. The cardinality is 61, but the semantic model is processed based on the physical view. Now, let's query the semantic model and add one more worksheet. Select the Sales Design Physical Design Semantic Model. There are only 5 dimensions in the query on the worksheet. Expanding the customer dimension reveals all its attributes. The physical design has 6 dimensions. The customer account dimension is added in the physical view. Kyvos identifies the need to get the response from customer account when you drag the account field into the physical view. Let's discuss the benefits of physical design. First, the reporting is not changed for the business users. For example, in a production environment, hundreds of reports are generated on the semantic model. If you identify any delay in query response, break down the customer dimension. We'll modify your business reports. To keep your reports intact without altering the model design, you can use both logical and physical views. This approach also retains the business perspective of a specific dimension. However, there are limitations when using these views. Dimensions such as time type, location type, or slowly changing dimensions, SCD, cannot be split. Only regular type dimensions can be distributed. Additionally, moving the hierarchy from one dimension to another is not possible within the physical view which restricts the creation of new dimensions with existing hierarchies. Optimization aims to enhance model build performance, improve query performance, and save costs and time by utilizing resources efficiently. The primary key areas when a semantic model is processed are semantic model size and its process time. It reduces the size of the semantic model and can significantly impact cluster costs. It can also minimize the time it takes to process the semantic model. There is a relationship between query performance and model build size. By decreasing the level of aggregations, we can reduce the model size, which might slightly affect query performance, but this impact is manageable. The aim is to strike a balance that meets query and processing SLAs. Let's optimize the design. First is design changes. Consider splitting dimensions into two to improve query performance. Second, use advanced properties to optimize the model. Third, cluster resources to identify proper materialization levels and use caching to enhance query performance. You can also tune the Kyvos cluster properties. Fourth is partitioning to improve query performance. Last is the data restriction definition, which defines a sliding window to limit the data in the semantic model. Let's discuss who can optimize. Business users should understand the reports to be generated, including commonly used fillers and attribute groupings. Kyvos users must be familiar with Kyvos properties and functionalities, including model views, partitioning, and aggregation strategies. System infrastructure experts should know the resources available for building and querying the model. We will discuss critical properties to optimize the Kyvos semantic model. These properties have already been tuned after learning from several implementations. In case a discrepancy is identified, you can retune these parameters. To optimize the semantic model, use the aggregation strategy. You can define the aggregation strategy, expert or smart recommendation. For expert recommendations, a thorough understanding of Kyvos properties is required. Let's discuss advanced properties. In the Refine tab, click Advanced Properties to view and set specific properties. From there, you can view a list of grouped advanced properties. Expand the group to select the specific property and set its required value. For example, in the Spark Properties group, configure the number of cores, executor memory, and overhead memory to optimize semantic model processing. Let's expand the Spark Properties group to configure Spark properties for semantic model processing to set the number of used cores to 4, allocate 15 GB to executor memory and 2 GB to overhead memory, set Spark driver memory to 5 GB. Configure the Spark Max Executor parameter to determine the maximum number of executors that can run simultaneously. Here, we will define the max executors. For this job, let's set it to 20. We can increase or decrease this parameter based on the available resources for our cluster, such as memory and the number of cores. For instance, we could set the max executors to 500, 1,000, or even tens of thousands, depending on the cluster's resources. In this case, we are using a very small cluster with only 4 nodes, so we have set the max executors to 20. Now, let's move to the query execution section, where we can configure various parameters for the query execution process. One important parameter is the shuffle mode, which helps shuffle records among query engines to enhance performance during query execution. This mode can take on 3 values: never, auto, and always. If we set it to never, the BI server must handle all response consolidation, which can overwhelm it and reduce performance. To distribute the load, we can shuffle the records to delegate the job to multiple query engines by setting this mode to auto or always. By default, shuffle mode is set to auto, allowing the query engine to decide intelligently whether to use shuffling. This mode is particularly useful for distinct count use cases. Next, let's see the query cache section. Here you can define properties to set the query cache strategy, such as the type and amount of cache. The query result cache stores responses to queries already executed on Kyvos. The cuboid cache strategy defines how the query engine's main memory is allocated for the Kyvos semantic model. You can also allocate the main memory among multiple models. Now, let's move to the aggregation strategy. Aggregation strategy helps optimize models by reducing processing time and size without significantly impacting query performance. There are 2 modes of aggregation: expert mode and smart mode. Let's understand these in detail. The expert mode is user-driven or configuration-driven. It allows you to tune your model performance by setting key materialization values and the pre-compute threshold level. The designer must have a detailed understanding of Kyvos properties to work in this mode. By default, the aggregation mode is set to expert. In expert mode, you can configure the following properties. Selective dimension materialization lets you choose the dimensions you want to materialize in your model from the list of available dimensions. Drag the customer location and product dimensions to the Materialized Dimensions section. The resulting model will combine records from these dimensions. Note that the dimension with the highest cardinality, time, will always be materialized by default whether selected or not. Even if we do not materialize the channel dimension, we can still query it using the aggregates created for the materialized dimensions. To change the dimensions for materialization, right-click on the product dimension, click on Delete, and drag the channel dimension to the materialization section to replace the product dimension. Click on Apply. Once configured, you can see the impact on process time and size in the semantic model process summary. Now, let's look at the selective hierarchy materialization. Change the materialization level of hierarchies. By default, all hierarchy levels are pre-computed, but you can choose the hierarchy level for model materialization. For example, click the drop-down field near the customer location dimension and select country to restrict materialization for location to the country level. Similarly, set the hierarchy level materialization for the product and time dimensions. Next is the degree of materialization, which lets you define the degree of materialization on a scale of 1 to 10. Note that combinations not pre-aggregated during model processing will be computed during the query runtime. Let us now understand the Smart Mode. Smart Mode is system-driven and automatically generates materialization based on queries. It allows you to filter or analyze historical queries and work with data profile information. Click the Materialization Level dropdown to set the materialization to high, medium, or low. Define query patterns for materialization by clicking on the Actions menu and selecting Set Query Patterns. Set the pattern and click on Save. Define the aggregation type for the aggregate structure by going to the Refine model, then the Advanced Properties section, and finally, the Aggregation section. To process the semantic model using Kyvos Analytical Store, select Tabular. Note that you need to rebuild the semantic model after applying this property. This marks the end of our session on refining semantic models in Kyvos. In the next section, we will understand how to run queries and generate reports in Kyvos Viz. Thank you.